Greetings and welcome, Internet friends. Mr. Waddy here, and we're going over part 2, the homework of solving solving quadratics using completing the square. It's possible systems of equations will show up in our very last problem. We'll see. All right, so solve the equation by completing the square. And so what's unique about this problem is there's a number in front of the x squared term. And easiest way in this case is to just divide everybody by a. Similarly, over here, divide everybody by a, and it'll make the completing the square process much easier. So over here, x squared plus 10x plus 22 equals 0. Let's bring the old c term to the other side, and I'm going to leave a space for my new c term, and we'll calculate that new c term. Let's see, did I give myself room? A little bit. All right, so I'm going to calculate this new c term right here. So the b is 10, so it's b divided by 2 all squared. So that's 5 all squared, which is 25. And so if I add 25 to this side of the equation, gotta be fair, gotta add it to the other side as well. And so now I can fast factor this. This is a perfect square trinomial, and it factors to be the square of a binomial. And so since this is plus, and it's just a plus b all squared. So it's going to be x and 5. Half of 10 is 5. It's always going to be the same number, the number I had before I squared it when calculating that b term. And this is equal to 3. And so now, since I've got this factored and the variable only shows up once, I can solve using roots. And so I'm going to get rid of this square by rooting both sides, plus or minus. Don't forget it. And so x plus 5 equals plus or minus the square root of 3. And now I can just subtract 5 from both sides. And so this is my exact answer, x equals -5 plus or minus root 3. They are looking for rounded to the nearest hundredth. And so let me write my little squeakle sign, grab my calculator. TI30x2s, -5 plus the square root of 3. I'm getting, gotta round this one, careful, -3.27. If you're doing the Big Ideas Math Online, pay attention. If you don't round proper, they'll probably mark you wrong. And -6.73 is the t'other one. All right, over here, what happened? So I divided everything by a. I got x squared plus 4x minus 7 equals -6. And so now I can add 7 to both sides. Yeah, I didn't make any sign errors there. Get rid of my old c term, you know what I mean? And x squared plus 4x blank for my new c term equals 1 blank. And so let's calculate that new c term. So c is going to equal 4 over 2 all squared, 2 squared, which is 4. So I'm going to add 4 here, and got to be fair, do it to both sides. Fast factor, x plus 2 all squared equals 5. Root both sides, plus or minus. Don't forget it. X plus 2 equals the plus or minus square root of 5. And then lastly, subtract 2 from both sides. Hey, quiet, bud. Dad's working. And I get -2 plus or minus the square root of 5 is the exact answer. The approximate answers, -2 plus square root of 5. I get 0.24. Had to round up on that. And minus is -4.24. Okay, so often quadratic equations will have two solutions. not always the case. Determine whether the quadratic function has a max or min. And so when we were doing this, we realized it was convenient to convert to vertex form. Which is this form here. And notice the square of a binomial in the middle of this. And so if I can complete the square a little bit, I'll be able to convert it to that form. And so the first thing I do, because a is not positive 1, I'm going to factor out a negative 1 from the first two terms. And so I'll have x squared is positive now, and plus 10x blank. Minus 30 and blank. And now, one of the things that's tricky about this one is there's different approaches that I've seen. I'm choosing to keep my blanks both on the same side, and so I'll have to make sure I'm extra careful with that, is all. So let's see. So find a new C term. So if B is 10, the new C is equal to 10 divided by 2 all squared equals 5 all squared equals 25. And so in the world of parentheses, I'm adding 25, but in reality, I subtracted 25. And so I would have had to subtract 25 from this side, except I'm working on this side. And so I want to add 25. And so this, by the way, this number is always going to be whatever a times my new c was. And then you've just got to be careful with the sign. So let's fast factor this. So y equals negative 1 parentheses x plus 5 all squared minus 30. And remember, the 5 is half of the b. It also is the number that I had right before I squared it. And so now it's in vertex form. A equals negative 1. Let's grab my sky blue. H equals negative 5 and K equals negative 30. And remember, the H is always the opposite of the number with the X. And so as a result, my vertex is negative 5 comma negative 30. And if A is negative 1, that's funny, I was hitting tab showing my inkwell there. If A is negative 1, that means it opens down. And if a parabola opens down, the vertex is on top. So it's got a maximum. And the maximum value is just going to be whatever the y-coordinate is. So the highest that this graph would ever get is at negative 30. Everything else is underneath that. Okay, so this one's a little bit trickier, having to factor out the value of a. Notice I'm not factoring out the greatest common factor here. I would have had to steal an x with it if it was a GCF, but I'm stealing just the a value. Okay, now this problem, I have a feeling you guys would have been like, oh my goodness, and I figured I'd help out here. Okay. You are building a rectangular brick patio surrounded by crushed stone. Border with a uniform width. A crushed stone border with a uniform width, as shown. You purchase patio bricks to cover 140 square feet. So the patio is this part right here, the blue part on my screen. I've inverted the image, so it was probably not blue on the original. And so that's 140 square feet. And so I've got to figure out the dimensions of these. And so if this entire width across is 20, and if this is an x and this is an x, then this dimension is 20 minus 2 of those x's. All right. If this entire height is 16, and this is an x, and this is an x, then the height of just this part, right, is going to be 16 minus 2x is what that dimension is going to be. And so let's write that equation. So the area, being length times width, will be 16 minus 2x times 20 minus 2x, and that's going to equal 140 square feet. And so the idea is like, okay, let's try to figure out how big this patio is going to be. And so let's distribute. 16 times 20, was that 320? 16 times negative 2x is negative 32x. Negative 2 times 20x is negative 40x. And negative 2x times negative 2x is plus 4x squared. That's equal to 140. Let's rearrange combine like terms. 4x squared minus 72x's when I combine these guys. And tell you what, let's say I subtract the 320 from both sides because I want to get rid of my old c. And 140 minus 320. It's the little things that screw me up. Negative 180. Now, I could go and factor out a 4 from these two terms. I could steal that 4. But I think everything, including over here, is divisible by 4. So I'm gonna divide everybody by 4. Yes. And oh man, that's a sneaky way to deal with it. That's gonna be much better. What is this gonna be? 18, I think. Let me verify. That's my guess. Ah, well done. 18x. There's a blank, and 180 divided by 4 is 45. All right, of the negative variety. Now, if you didn't notice that, yes, you could have factored out the 4 and completed the square, and you'd had to add AC to the other side. Yeah, it'd have been a little bit inconvenient, but you still would have gotten the same answer. So let's see. For my new C term, I'm going to take negative 18, divide by 2, and square it, which is negative 9, all squared, which is 81. So I'm going to add 81 here and add 81 here. If you did the factor out thing, I think you still would have ended up having to add 80. No, it would have been whatever 4 times 81 is, I think, yeah. So let's see. Let's fast factor. So here's going to be x minus 9 all squared equals 81, take away 45, 36. What? Oh, wow, it's friendly numbers. Was not expecting that. Root both sides, plus or minus. Don't forget it. X minus 9 equals plus or minus 6. And now if I add 9 to both sides, I get x equals 9 plus 6 is 15, and 9 minus 6 is 3. Now, it's possible this has 2 answers. Algebraically, it does have 2 answers. But let's take a look back at the original problem. 16 take away 15 would still give me a 1 foot. Okay, I think that works. And 16 take away 3 would still work. Okay, I don't end up with any negative dimensions here. So it's possible. Yeah, maybe it's got 2 solutions. It's possible. It's possible. So let's see. What would I have to do now? Find the width of the border. Oh, no. Aha, the x this time can't be 15. Why? Does anyone see it? I was thinking 15 is this dimension, but that's not what I solved for. I found the width of the border, which I can't have 15 on both sides, because if this is 15 and this is 15, that adds up to 30, which is bigger than 20. And so I'd have like a negative overlap area that doesn't work. And the same thing here. 15 and 15 is 30, which is more than the 16. That's not possible. Okay, so the border is 3 feet. So 3-foot border. And fortunately, this problem didn't ask me to do any unit conversion or anything like that at the end. Okay, let's see. I might just do, well, we'll see. Okay, here's 65. I was saying maybe I'll just do the setup, but let's find out. You have 80 feet of fencing to make a rectangular horse pasture that covers 750 square feet. A barn will be used as one side of the pasture is shown. So I don't need fencing on this edge. Okay. Write equations for the fencing to be used in the area enclosed by the fence. Okay. So let's solve for W. W for Waddy. So I know that W plus L is going to equal 80. So I know that 2W plus L is going to equal 80. And tell you what, it says solve using a system of equations from part A. I'm going to solve for L and then try to write everything in terms of one variable. So watch this. If I subtract 2W from both sides, I'd get L equals 80 minus 2W. And so I'm going to argue that this dimension is 80 minus 2W. And so now the entire perimeter is, right, W plus 80 minus 2W. That doesn't actually give me new information, does it? No, I can't substitute it back into its original form. Okay. Well, what do I know? I know, here's my other fact. I know that the area is got to be 750 square feet. So I've got W length times width. All right, length times width. L times W is equal to 750. Now here is where I can do my substitution. I'm going to plug this in for W, and I'll have 80 minus 2W times W equals 750. All right, now, so I had two facts. I had this fact, and I had to substitutify in order to solve there. Okay, so now here's an equation in terms of one variable. That's solvable. Let's distribute. And so I'll have W times 80 is 80W. W times negative 2W is negative 2W squared equals 750. Now in this case, everything is divisible by the negative 2, so I could do that. The other thing I could do is factor out the negative 2. Either option, but I'm thinking the divide step is much easier. And so I'll have W squared minus 40 dubs blank equals, is that 375? Yeah, it's too high stakes for me to make mistakes. You know what I mean? Negative 375 blank. Okay. So now let's find our new C term. Actually, you know what? I'm tempted to have you guys keep working on this. I feel like I've gotten you most of the way. Yeah, I'm gonna do that. I've gotten you through the awkward part of the substitution, and I want to let you guys struggle it out a little bit. So take it away, Squidwards. Y'all have a good day. Adios.